All right. Welcome back, everyone, for Advent of Code Day 23. Just ate a muffin. So, excuse me. All right. So, a couple things. I hear today is kind of challenging, so looking forward to that. Also, I may need to pause the stream in short notice because we've apparently got a plumbing issue where I live, and they might need to come in and take a look at something. Hopefully everyone's wearing personal protective gear. Well, I'm gonna make sure that. Gotta have a mask. Don't want to spread COVID. Stay safe out there. All right, so I guess let's get started on day 23. All right, here we go. What do we got? The small crab challenges you to a game. Okay, this is a new game, I guess. The crab is going to mix up some cups, and you have to predict where they'll end up. Okay. Cup game. The cups will be arranged in a circle and labeled clockwise. They're in a circle, labeled clockwise, your puzzle input. For example, if your labeling were 3, 2, 4, 1, 5, there would be 5 cups in the circle going clockwise around a circle from the first cup. The cups would be labeled 3, 2, 4, 1, 5, and then back to 3 again. Okay, so we got a circle of cup, they're clockwise. Before the crab starts, it will designate the first cup in your list as the current cup. The crab is then going to do 100 moves. Okay. Each move, the crab does the following actions. The crab picks up the 3 cups that are immediately clockwise of the current cup. They are removed from the circle. Cup spacing is adjusted as necessary to maintain the circle. Okay, so he's splicing 3 cups out of this circle, out of a circle. That's okay. The crab selects a destination cup. The cup with a label equal to the current cup's label -1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value on the cup's label instead. The crab places the cups it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. So the crab selects a new current cup, the cup which is immediately clockwise of the current cup. So for example, okay, here we go. This is probably where we'll figure out what this is doing. So suppose your cup labeling were, if the crab were to do merely 10 moves, the following changes would occur. So it's 3. So he picks up 891. Okay, yep, there you go. He picks up 891 and the destination is 2. And why was the destination 2? It was a destination, the cup with a label equal to the current cup's label -1. Okay, because so it's 3, so he looks for a 2, and 2 is here, so then he picks up 891 and he sticks it after 2. Right, so this gets spliced from here into here. Okay. And so now he picks up 891 because it's to the right of 2. So the current cup becomes that. Okay. So we find a current cup. We splice 3 out. We try to find the next lowest number. And then we put it back in. And then we pick them up again. And destination is 7. Well, that's weird. Hold on. Maybe I don't understand this properly. Destination cup. Crab selects a destination cup. A cup with a label equal to the current cup's label, -1. If this would select one of the cups that was just picked up, Oh, because it selects one of the ones that was just picked up. So, right, he would want to select one, but one isn't available in the list anymore. So he would have to select 7 because it's the highest value that now exists, because it would have wrapped around, and then move 3. So he puts it after 7, so it becomes 7, 8, 9, 1, and then he moves from 2 to 5. So he grabs 4, 6, 7, and he would want 4, but he can't have 4, so he wants 3, so he puts it after the 3, destination 3. Yeah, so then he puts 4, 6, 7 after the 3. It's weird that it's written like this. I guess it doesn't matter because it's a circle. Okay, so he puts it after the 3. So it would be 4, 6, 7, 2, 5. 4, 6, 7, 2, 5. Right. That was his destination. 4, 6, 7. And okay, so now he's got the 4, 6, 7, and it's after the 3. And the 3 would have would have looked for a 2, and the 2 would have been 5, 4, 6, I thought. New current cup was immediately clockwise. Oh, no, he's just moving forward. Okay, so the next cup is the clockwise cup. Okay. In the above example, the cup's values are the labels as they appear moving clockwise around the circle. The current cup. So every cup is going to have a next cup, and it's going to be in an infinite ring. This is kind of this feels like a linked list, which is something I think I've only ever used in programming challenges. It's like something you virtually never use. But maybe we can try to use it. So what is a linked list? A linked list is basically just like a series of items. It's kind of like an array, but where you have a value and a pointer to a next value. So it's good for creating things like rings, and it's good for if you just want to maintain a list that you can like pull stuff out of. So when you pull stuff out of a linked list, basically you take the thing where you're starting and the thing where you're ending, and you take the values in the middle, and you take the next from the last value and assign it to the 0th value, like the one before the slice. So let's try this. Let's copy that, and we'll see if we get anywhere with this idea of a linked list. Otherwise, maybe we could just, we could apply the same concepts. New folder. Day 23. Oh wow, that's capitalized. Got my caps lock on. No file. Let's rename this first. Day 23. All right. Lit coffee. Yeah, come on. There you go. All right. The following actions. Plain. I guess these could just be like list. Okay. I guess this could be, oh no, that's not numbers. It would be 1 dot. Yeah, this is what makes it like a numbered list. Let's make it a numbered list. Let's get fancy with our, and these can be actual numbers. Anyway, plain. All right, we got our moves. Inner final. Okay, in the above example, your puzzle input is, oh, look at that. Our puzzle input is just a thing. So we can just grab that and say input equals, we don't need triples. In fact, it can just be a number. Actually, no, it should be a string because it's a string. Okay, so we got our puzzle input, and we're gonna make our 3 sections that we always make, where we define things, where we test things, and then where we run the code to get the output. Cool. So let's jump straight into our setting up our tests. So we're gonna get log, just so I don't have to type console.log and misspell it all the time. And we'll get assert, because this is how we can just assert that it continues to work as we refactor once we see it working. All right, and now what are we doing? So the first thing we're going to need to do is we're going to need to parse the input. So let's, whoops, not Ruby, parse input equals, and we're going to get a string. Oops, I don't know what I'm doing. String equals, whoop. And really it's just going to be string split on nothing. And then since we're gonna be dealing with these as integers, I'm gonna map them through parse float. I've mentioned this before, but I'm gonna mention it again because why not? It's a good tip. Parse float. I like using parse float instead of parse int because parse int has burned me before, where I pass in a number and maybe the number is a 0 or something, and it ends up thinking like the first digit is a 0 and it thinks it's octal. Whereas parse float always assumes that the number is decimal. And numbers are just numbers in JavaScript, so it doesn't matter. So let's see if this is working. Parse input, and we'll just see what we get. We get an array of numbers: 4, 6, 9, 2, 1, 7, 5, 3, 8. Cool. So what do we have here? We're gonna have, so what is a linked list? It's kind of like an array where you've got this item, and the item has a value and it points to the next value, the next value. So this could be item 1, and then you've got item 2, so item 1 might point to item 2, and then item 2 might point to item 3, and then you got item 3, and that might point to item 1, and that's your sort of like, that's your circular structure. I mean, it's not even an array, it's just items pointing to items. And then if you wanted to chop out item 2, say, hey, find the thing that points to item 2 and point it to whatever item 2 points at, 3. And then this gets chopped like that. And then those are the list, that's the list basically. The only other part to this would be you need, since it's not an array like this, you can't just be like, give me the list. You actually refer to it by pointing at one of its members. So, and I think they call that the head member. Is that the head of the list? Even though it can be circular, there's like the head. So you might have a list where the head is pointing at 1, and then you've got just items just floating around all nebulously here. So I think what we want to do is we're going to want to create a list with a head that points somewhere, and then we're going to want to just have items. I don't think JavaScript has anything like this built in, so we're going to have items, thing like this built in. So we're going to list, and this constructor can take a head, which doesn't need to exist. We'll just assign that to a value. And I don't know if we're going to need a class for that actually. And class item, and this is also gonna have a val. Oops, a val or value val, and next. So next equals null, val equals null, and so this next can just be a reference to the next item in the list, and then we can add other things here, like we can add, like move next or whatever. It can be a thing, and it can just return, or I guess next will just be that, and we'll just return the next item. Anyway, we can add things on here as we need. So if we need to, like, maybe we need to find item with value, then it can, start at head and just like go next until it finds a value, that kind of thing. But we'll get into that as we as we get into it. All right, so let's remove those. So I guess really what we want to do is we want to, so we've got this parse input. This is returning an array of integers right now, and we probably want to return a list with an array of items. So list. So let's grab a new list, and the head can be null for right now. And then instead of mapping to parse float, what we can do is we can say val equals parse float val. We can just parse the float in here as we construct it. So we can map the value here to new item v. Okay, and then we're not assigning. I guess we could assign next. Maybe we should be doing that. Index. Okay, so we're going to, so that's map. So let's say array equals string dot split, and then we can just say for array v index in array. We can make a new item v, and we can point it at the, so we'll want to point the new item. So we'll want to say we'll want to track the previous item. Basically, we'll want to say our index -1. So that'll be our previous item. That'll be our next. Oh no, that's not true. What we'll want to do is we'll want to find. Yeah. Okay. So we're gonna need to keep a reference to our previous item. So we're going to keep previous as null, and so for v in array, what we'll say is item equals new item v. We'll say prev dot next equals item, like that, and then we can say prev equals item. So let's see if this works, and then we'll point the list at the first item. So we'll say list. I guess we can just do list dot head or equals to item as well. Okay, so that's parse input, and then I guess at the end of that, we're actually going to return a list. So let's see what we get back for parse input. Okay, so next equals, it didn't like that. Okay, so list, head, item, next, item, next, item. So interesting. And then, oh, one last thing we're going to want to do is we're going to want to point the last, so we're setting the previous, if there is a previous, we're setting its next. So this isn't a circular list. YouTube's yelling at me. It's saying that there's not enough video data. So I'm sorry if the stream is getting all screwed up. I hope that it is working. Okay. Now it's an excellent condition, so I don't know. Okay, so we've got our first item points to the next item. That's weird. There we go. And that points to the next item. And then the last item never points to the first item. So let's do that. So if the index is array length -1, so if index is length -1, so if we're at the last element, what we want to do is we want item dot next to be equal to list head, which is the first item. Okay, so this should give us a nice circular list. Okay, so we've got this list. So let's just double check that we've got a circular list. List equals, and then we're gonna say log list dot next dot val. Oops, list dot next is not a function. Oh, next cannot. Oh, head, right? List head. So let's log list head val is 4. Next val is 6. Next val is 9. Next val is 2. Is this 9 2? Where is it? 4 9 2. So let's do this a bunch of times. Copy, and we want to wrap it around. So now we're at 3, which is the second to last one. And this is 8, which is the last one. And then let's try another one. And that goes around to 4. Okay, cool. So we've got we've got a circular list, which is cool. So we're gonna need a way to find a value in the list. So let's make a find. I have no idea if this is the right nomenclature for a linked list. I'm pretty sure head is right. I'm pretty sure next is right. I don't know if there's a way to find, maybe it's like seek or search, or I don't know. Whatever, we're making it up as we go. So what we'll do is we'll say while val equals, so first I guess what we'll do is we'll get a node or an item. Item equals head. It's supposed to be an equals, okay? And while val equals item dot, I guess what we want to do is we want to say until item dot val is, you know what we could do, which should be really shitty. We could we could make the list so the list has a value, because JavaScript's interesting because everything in JavaScript is an object. So what we could do is we could just effectively make a class that extends a number, and we could add a next to the number. I wonder if that would work. I mean, we can try. Let's try that. Let's just do class num, and that would, no, you know, this is just weird. It's weird. I'll burn like an hour playing with that, and then it won't work. Okay, so until item dot val is val, item equals item dot next. So basically we're going to loop over these, and what if the value's not found? So let's first item equals item. Okay, and so if item is first item, oh, I guess we have a reference to that, which is the head. So if item is head, then we want to return null. So this is just going to say, hey, give up looking for it. It doesn't exist. But we want to do that here after we've already checked for it. So, okay, so we're going to say until item val is val. All right, what we're doing is we are going through the list and we're waiting for until we have an item. And then we can say return item. So if the head item value is value, then it will not do this at all, I don't think. And then it will just return item. And if it isn't, then it will go in here and say next, and return null if we're back at the head again, until it finds it, and then it will just say item. Okay, so let's try this. Let's try list dot find, and then let's find a value. Let's find 2. Item val 2. Cool. Let's try 8. Good. Let's try C, v null. Okay. So I mean, this seems to work. And what if we try to get the one at the head? Let's try 4. Cool. It finds it. All right. So that's good. So we've got a find. Now we should implement these. Okay, so what else are we going to need to do? So we've got this way of finding a thing. We also need a way to slice the list, basically. So we need to take a list out of the larger list, and then we need a way to put it back in. So we're going to need a way to move. Is it always 3? 3 cups. Okay, so it's always 3. So we could make one method. It always picks up at an index. It picks up 3 and then drops it off at another index. And the other index needs to be calculated. But that's based on the current index and whatever would be left over once we took these out. So, all right, so let's talk about what that is. Let's transplant. I guess transplant is going to be a long, hard word to type. Let's say just move. And move is going to take a current, which is going to be like a current value. So it's going to move from after a value, and it's going to move. It's always going to move 3 items. So let's call it move 3, and it's going to move it to 1 minus value, and that's the target. Target is going to be so target equals val minus 1. So that's what we're looking for. And then what we're going to have to do is we're going to have to find the next 3 items. So we're going to have a way of getting the next 3 values. So I guess what we should do is we should, oh, you know what? It's always going to move from the head, so we don't even need this value. So move 3. It's going to be head.val minus 1. Okay, so that's our target. That's where we're trying to move the items to. So we could either take the items out and then repair the list and then put the items, inject them somewhere else. I think that probably makes the most sense. So let's have an operation that, I guess, isn't even an operation. What we're going to say is we're going to say okay, so we're going to need to slice 3 out. Whoops. Slice 3 out, and then put them back after. So we're going to have to slice 3 out, repair the list, move head to next, and then when we move the head to the next, yeah, let's take a look at the thing again. Okay, cool. So the crab selects a destination cup. The cup with a label equal to the current cup's -1. If this would select one of the cups in the thing, then it just keeps subtracting 1 until it finds a cup that wasn't picked up. Okay, we're gonna have to implement that. If at any point this process, the value goes below the lowest value on any cup's label, it wraps around to the highest value on any cup's label instead. Okay, the crab places the cups it just picked up so that they are immediately clockwise to the destination cup. You know, it might be helpful to just have it, like, we're making it difficult for ourselves to have to iterate on the items all the time. It might be helpful if what we do is we make a new list with string or with array maybe. Yeah, let's do that. Okay, so we're gonna make a new list with string split on nothing and then map parse float. And so why am I doing this? I mean, we can just pass a string into the new list. And then the list constructor can do this stuff for us. So the list is no longer getting a head, it's getting a string and a head. Okay, and then string split, whatever, map parse float. So this is going to be values equals. Okay. And then what we're gonna do is we can just do this stuff in here. Okay. So now so we'll have the list itself make the items in values, new item value, and the previous item next equals item, and then head equals item, and if head. So do we have any lists in here? Let's see if this still works. No, something's broken. R is not defined. Oh yeah, this is going to be values. And you know what? Let's make it this dot values. And then that way, what we can also have is we can have max val, and this can be math dot max values. I really do prefer the spread at the end. I guess it's like Ruby rather. And then we're gonna do min val. Okay, so now we got max val and min val, and okay, finding that still works. Cool. So we're gonna slice 3 out, repair the list, move the head to the next, and okay, and then the crab places cups just picked up, so they are immediately clockwise of the destination cup, and then selects a new current cup. So that happens later. Okay, so repair the list, and then we want to find the target or the destination. I guess we can call it destination. Insert the slice. So yeah, okay. So this is what we want to do. So we're gonna slice 3 out. So what does slicing look like? Slicing is basically we want to, we're at the current, so we want the next item. So next equals head dot next. And you know, it'd be cool if we could just like have like a next 3, or like let's call it peak, and we'll have an int like, or a num, and peak 0 would look at yourself. Peak 1, 2, and 3. Peak num equals 3, and then we can say for I in 0. There you go. We can say target equals head, and then target equals target dot next for I in 0, 3. So this would look at itself, not including 3, and that would be num. So it would look at itself, then it would look at next, 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 and then it would return target. So let's see if this works. So target, so if we're at 4, if we start at 4, target of 3 should give us 2. Let's see. List find 4 dot peak 3. Okay. Find peak is not a function. Oh, because find is returning. Oh, it's an item. Oh, it's an item. It's the list that we. Oh, that's right. Okay. So it's the list that we need to peak, not the find. So this should be the head. Okay. So that gives us 2. So we're at 4 and it peaks 3. So that would be item 2. And so 1, 2, 3, 4. And so we're going to want to peak 3 and peak 4. I guess peak is weird. How about in 3? So list, I guess we could call it right 3 and right 4. Okay, so it's always going to be num. Let's make sure that we give an actual num, so we'll just say num 0. Okay, so right 3, this gives us that, and then log list right 4 should give us the next one, which it does, val 1. Okay, cool. So what are we doing? We've got our current head, and we want right 4. So we want the start to equal right 1, and then what we're going to do is we're going to set the end equals right 3. So we've got our start and end, and we're going to say end dot next equals null. We're going to have to do that after we get the new next equals at right 4. Okay, so now we've got our references. So we've got head still. So we're going to say head dot next equals new next, and we're going to say end dot next equals null. So that way we've got 2 lists here. Man, that's a pain. Okay, so we've got our start and our end, and we've got our new next, which is right 4. I guess we don't even need that. We can just say like that. Head next equals right 4, and then end next is null. Cool. And we need this head next. We need to set this before we set this, or else we'll break the chain. It's cool. So we've got our sublist, which is just basically start. That's all we really care about. Maybe we don't need. Yeah, we just need a reference to this, so we can do that after. Okay. So slice. Well, I mean, yeah, whatever. It's fine. It would be fine if we didn't, because we're going to overwrite it when we put it back. So this is slice 3 out and repair the list. Okay. And now what we want to do is we want to find the destination So now that we've got a repaired list, what we want to do is we want to figure this out. We want to figure out what our destination is. So we're looking for the number that is smaller than this by 1 if it's in the list. And then, so that's what we're going to use find for. So this is an integer. Whoops. Come here. So let's do that. We're always going to have an answer, so we don't need to worry about breaking on that. What we are going to need to do is we're going to say, here, let's just do well true, and we can say, I guess we're going to say dest equals head val, and then we're going to say, well, we want to find, I guess, until find dest. We want to say dest equals, so this is a dest, this is going to be dest val, and that's what we want to find, until dest equals find dest val. We're going to have to change what dest val is. So dest val will be minus equal to 1. And then if, oh, you know what, we're gonna have to, this min val and max val, we're gonna have to look, oh, no, that's fine. If dest is less than min val, dest val is less than min val, then we're gonna set dest val to max val. Dest val equals to max val, and that's how it loops around. Okay, so that's, then we're gonna have a dest. So that should be a guarantee. We're always gonna find a dest. And then, so what's next? So we need to insert the slice at dest. So we're going to dest dot, so this is going to be the new end equals dest dot next. Dest dot next equals start, and then end dot next equals new end. This is one of those patterns where I think what we could do is we could actually set them like this. No, I don't want to do that. I want to go down that rabbit hole again. Okay, I was just thinking what we could do is we could do like fancy destructuring where we just sort of like do the swap, but I'm not going to do that because I remember doing that earlier and it led to confusion. I don't think it'll be the same because we're doing like an assignment on an object. I think that only works if you're swapping value, like simple variable values. Anyway, so that's insert the slice and then put them back after. I don't know what we're talking about there, and move head to the next. So so move 3, well, let's just move 3, but what we really want to do is we want to, what we want, and you know what, move 3. I mean, the only real reason why 3, so this is going to be move, I guess, and cups equals 3. And then this can be cuppos, and then cups plus 1. Yeah, and then that's fine. Then we've got this variable number of slice cups out. Repair the list. Okay, move head to next. So this is going to be, I guess this is going to represent an entire move, an entire shuffle. Or we could do shuffle the cups, and then we're going to have how many cups? 3, and then we can have move cups, and then what we can do is we can just move to the next. So we'll just say at head equals next, or head dot next. So move the cups, and then move the head, or advance the head. Okay, so we should probably have a way of printing this list out. So let's write that as well, because that will come in handy for debugging. So what do we have here? We've got cups, and we've got our current head in parentheses. I mean, we could replicate this. That might be pretty fun. And then it says pickup and destination. So let's yeah. Let's just print the list, or we could toString, and what we'll do is we will say for, I guess what we want to do is we want to say until item val, or we want to do, yeah, until item is head. So we're going to we're going to have return values equals an empty array, and we're going to head dot val, and then we'll go so I guess what we'll do, until item equals no, we want to, until item is, we want the previous one here. That's the problem. So we're gonna have to call item equals head dot next now, and until item is head again, we'll say, you know what? No, we don't want to move the head. Actually, we want to say head equals head dot, or I guess we'll just do head like that, and then we'll want to do head val, and then until item equals head, and then head equals head dot. This is like a local head. And then until that is true, what we're going to do is we're going to ret dot push h dot val, and then head equals head dot next, and there's no item here until, oh, there is item. So yeah, right, item, this should all be item. Item equals item, and this is fake head, is head item dot val, and then we can say item equals item dot next, and then finally what we're going to do is we're going to log just ret join, let's give it some spaces. So let's see if this works. So we should be able to just log list like that. Okay, 4, 6, 9, is that what the list looks like? 4, 6, 9, 3, 8, cool. And let's advance the list. List dot head equals list dot head dot next, and then so that should be 692 4. 692 4. Okay, cool. Neat. All right. Now we've got our logging. Now what we should do is we should try to move an item in the list. And I guess, you know, we can just log list toString, and then that way log list to string. So is toString logging? Is that, yeah, we're logging. We don't want to do that. Okay. Is to that. Okay. And we can just coerce it like this. It's probably easier. There you go, log list. So let's call move or call shuffle and see what happens. So head will always be in the first position this way. So let's dot shuffle, and it's going to shuffle 3, and then we're going to log list again. Okay, so it took 4, so it was at 4. It should have taken 692 and moved it after 3, and it did, and then it moved to the next one, which is 1. Okay, cool. So that's given, oh, that's the puzzle input. So let's try with the, so that should go here. But let's try with the fake input. Where's the fake input? It was here. So since, I mean, there's always just here, we'll just do that. Cool. So we shuffle once. So 389 becomes 3289. No, it becomes, yeah, 2891. 5, 4, 6, 7, 3, and then let's shuffle a second time, and now we should be at 5, 4, 6, 7, 8, 9, 1, 3, 2. Okay, cool. And now if the crab were to do merely 10 moves, so that'd be move 1 is 3, 8, 9, 1. That's not a move though, right? So that's the beginning state of the move. So after 10 moves, it should be that. So, okay, so let's just string it, and let's assert that. So, and maybe what shuffle should do is instead of taking the number of cups to shuffle, because the cups is always going to be 3 for now. I guess what we can do is we can say shuffle times cups. So for I in 0 up to and not including, or up to and including 1. No, up to not including 1 times. And then we're going to do that. And then at the end, we're going to return the list. Okay. So if we shuffle 2 times, we should get 5, 4, 6, 7. And we do. Okay, so let's shuffle 10 times, and we get 8, 3, 7. And is that what they were saying? 8, 3, 7, 4, 1, 9, 2, 6, 5. Yeah, so that's the final. What are the labels on the cups after cup 1? Oh, the labels on the cups after cup 1. So starting after the cup labeled 1, collect the other cups labels clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. Okay, so I guess we can just add, I mean, we could move the head to 1, but we can just say labels after 1, and that can be find 1. So that's going to find 1. And then it's going to do this basically to string thing, except instead of starting at the head, we're going to start at find 1. Cool. And then instead of, we're not moving the head. Okay, and we're gonna join with nothing. So labels after 1. And what are they asking for? So on producing this, if the crab were to complete all 100 moves. Okay, so we don't want 1. Cool. Okay, so labels after 1. So let's see what labels after 1 would be here. Log list dot labels after 1. Ooh, ret is not defined. I guess labels after 1. All right. Let's put it in here. Ret equals that. And you know what? Let's do that as well here. Ret equals, and then we can just ret push initval. Ret push initval. Okay. So 9265, and is that what it wants? 9265 8374. Yeah. Okay. Cool. If we're to complete all 100 moves, the label after cup 1 would be 6738. So let's try that. Okay. 100, and look at labels after 1, 6738 4529. Okay, cool. Using your labeling, simulate 100 moves. What are the labels on the cups after cup 1? So gonna have list equals parse input that. We're going to list shuffle 100. And labels after 1, we're going to assert that is list labels after 1. And shuffle returns 100. Whatever. Cool. So that doesn't assert. Asset is not defined. Assert. Cool. And then we're going to shift level, and then we're going to say log. Okay, so this should give us the answer. So these are the things, and there are 8 values. None of them are 1. They don't repeat. It looks good. Let's try it. That's the right answer. Cool. Okay, continue to part 2. Due to what you can only assume is a mistranslation, you're not exactly fluent in crab. You're quite surprised when the crab starts arranging many cups in a circle on your raft. 1 million in total. Wow, my dog is really upset about this. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in an increasing fashion, starting from the number after the highest number on your list and proceeding 1 by 1 until 1 million is reached. So if your labeling were 54321, the cups would be numbered 54321, and then start counting up from 6 until 1 million is reached. In this way, every number from 1 through 1 million is used exactly once. After discovering where you made the mistake in translating crab numbers, you realize the small crab isn't going to merely do 100 moves. The crab is going to do 10 million moves. Wow, I hope this is fast. Okay, I have no idea how fast this is going to be. The crab is going to hide your stars, 1 each under the 2 cups that will end up immediately clockwise of cup 1. So you can have them if you predict what the labels on those cups will be when the crab is finished. Okay, in the above example, this would be 934001, and then, okay, multiplying these together produces determine which 2 cups will end up immediately clockwise of cup 1. Okay, so, I mean, like, I guess these items might be expensive to produce 1 million times, and really all we're doing is we're assigning a value to it. So this finished in 2 seconds. Let's see or 0.2 seconds. Let's see if we can get away with just sticking a value onto an integer. And then, so everywhere in here, so let's start with number 2. New file 2.lit coffee. So the reason why I'm thinking this is because I'd really prefer not having to make a new object a million times. I feel like that would be slow. So item equals v, and then everywhere we have .val, I don't think we're gonna want .val anymore. .val, and so this is kind of what I was talking about earlier. Can't create property next on number 3. Okay, so this is what I was kind of afraid of that. I was hoping that we'd be able to create a next on number 3. What we can do is we can create a function next. So we could create a map with a million entries that is effectively our pointer map. Well, let's see how slow it is first, because you know what, maybe it's not too slow, and we'll find that out. So this is our new text, part 2. Okay. In the above example, the 3891, which is our test input, this would be that, and multiplying them together is that. Okay, so, whoops. Okay, so we're gonna want to assert that this is the label for 1. Is list dot find 1 dot next dot val, and we're going to assert that that is find 1 dot next val. So this is what we're going to be asserting, and we're not going to be shuffling this anymore. And multiplying those together. Well, I mean, yeah. And then here we'll just say assert is list dot find 1 dot, I guess we'll want to say product after 1. Okay, is, and we can say value after. Let's just do that. Okay, so let's make list value after, which is, whoops, value after 1. Okay, so value after, and this takes a val, and that val is going to be an integer. So we can say at find val dot next dot val. So this is going to give us find 1, and then give us the next item, and then read the value of that. And then we can find, what do we want? We want product after. Okay, so, and then product after, where are we here? Product after is going to be very similar. So it's going to be, so first equals value after val. Second equals value after first. I guess we can just say first dot next. I guess what we want is find val next dot val, and then this can just be find val next dot val. I don't feel that bad about this. So and then we can say first times second. I guess this can be item 1, item 2 equals item 1 dot next. And in fact, yeah, I mean, this could just be fine, whatever. First time, this is gonna be item 1, val, and item 2 dot val. Okay, so product after. So value after. Let's just find val next. Okay, product after. Okay. Cool. So we've changed the input rules, which is that we do the input as normal, and then from the max value to 1 million. So we always get 1 through 9 basically, don't we? Through 9. So the max value, what we had here for max val, which is max val values, I mean, that's always going to be 9 in the first case, and here it's not. It's going to be 1 million, and the values array is really not going to be useful. So I don't know why we're doing that. We don't need to keep values. So we do values here just to set them in, and then we have max. Okay, dust val equals, and in this case it's going to be 1 million if is lower than 0. Okay. It is 1 million, right? Yeah, 1 million in total. Yeah, okay. Cool. So we've got this constructor. So once we have done the first 10 of these, we're going to say for v in, I guess what we're going to do is we're going to just basically say, yeah, for v in, I guess values dot length, that's going to be 10 up until and not including 1 million. We're going to do the same bullshit here. Oh, and we're not gonna do that. We're gonna do this, and then we're gonna have prev is still gonna be set. So we're gonna say prov.next equals head at the very end. Okay, so I mean we can try this and just see how long it takes to run. So it failed fast. Oh, look at that. Okay, so assertion, that's cool. So let's log list value after 1, 2. Okay, so oh, well, we didn't shuffle it. We need to shuffle it 10 million times is what we need to do. Jesus. Okay, and then 1, 2. Okay, so at least it found that. So let's shuffle it 100 times and then see what it is. So shuffling it 100 times give us a 3, 1,000 times. Okay, this shuffle is starting to be slow. I thought the object creation would be the slowest part, but it's not. It seems to be the shuffle. 10,000 times. Yeah, this shuffling is pretty slow. Maybe we can find a way to make the shuffling faster, because it's going to be 1,000 times slower than 10,000, because we're supposed to shuffle it 10 million times. So maybe what we're going to need to do is we are going to need to create an identity map, basically, so or a pointer map. But even then, creating creating a 10 million key or a 1 million key map is going to be annoying. So this still gives us 3 after list shuffle 10 million. Well, what are we actually doing here? When we think about the rules that we're applying, like we always find the one that's lower than, we start again at the end, and we go back. And we move lower. And then we want to find the value after 1. No, so that is going to be I mean, yeah, okay, we are going to need a high number. Okay, so that took 51 seconds, so it's going to take 1,000 times that if we don't do something different. So what is it? What's slow about it? Is it the item or is it the find? I guess item equals item dot next. Yeah, it's probably find. So can we, maybe what we can do is we can just maintain our, maintain our indexes here, and so the items don't need to be, so these items aren't doing anything, it's just a constructor with a value in it. So I feel like maybe what we can do is we can just so it's got a value and it's got next, so it's got a property. So what we're going to have to do is we're going to have to swap out this next for a next method, and then we're going to have to keep next as a map. Let's try that. So we can next map equals, there we go. So we could do it either with an object, and that object what the object can do is it can store the value and then the next value, but it's going to store them as strings. The other thing we can do is we could store it as an array of 10,000 items, and then we can be the value, and then the value be the next index. I wonder what would be faster. If it's not sparse, I have a feeling the array is going to be faster. But if it is sparse, which it's not, then I think object would be faster. We could try both. Let's try it with an array. So this is going to be the next map. So the index is going to be the number, and then the value is going to be the number of the next index. Okay, so we got next map. And so item is now just v. We don't care about next anymore. And we're just going to have an array of new array of 10 million objects. And it's only the first 10 that we're going to be shuffling. So we don't care about this anymore. So for the index and values, we're going to say next map at v so first of all, we're going to say at head equals, so head is just going to equal 0 right now. No, it's going to or equal to v. And v is only 1 through 9, which is 9, and there is no 0. So I guess 0 we'll just ignore for now. Okay, so head, we have to set head to something. So that's going to be set to this value. And then what we want to do is we want to say next map next map so next map of head next map of v. So we don't know. Okay, we do have to store previous, so we're gonna say priv or equals to v, and say if priv next map at priv equals v. Okay, and then priv equals v. What's all this crap? Next map v. No. Okay, so we're going to assign head if it doesn't exist. So that, I mean, we could do that here. Head equals values first. Okay, so we got that. Now we're going to start with previous equals null, and then we're going to set the next map of previous to this value. I guess what we could do is we could just say next map of index +1 is equal to the value. And then we don't need to worry about the previous. And then these next maps would be fine. And then we just ignore 0, and head would be the first value. Okay, yeah, I don't think we'll need to do any of this stuff then. Okay, so I mean, really all we're doing is we're saying next map is these values and then followed by the rest of the array. So maybe that would be easier. What we could just say is next map equals 0, and then we could have values dot length up to and not including that, and then we don't need to do any of this crap. Okay, let's just comment it out for now, and then we can just say next. We don't have to do next map. So let's try that. Here, I'll just put it right here. Okay, yeah, we're still gonna have to do that. In fact, we could actually make this a lot simpler. We could just say next map equals 0. I guess it would be 1 to up to and including 1 million. So that would be 0 points to 1. I don't know if that's what we want to do. I think we do want a 0, and the head will just never get there. Well, let's think about this. So, all right, what are we gonna have? We're gonna have our next map is gonna be an array. Here, let's move it out of here just in case. So it's gonna be an array, and we're gonna have the 0th element. So this won't be a thing. And let's say we're just given the numbers 1, 2, 3, 4, 5, or whatever. We'd have null. So then we would have 1 would point to 2, 2.3, 3.4, 4.5, 5, 6, 7, 8, 9, and then 9 would point to 1 again. 9 would point to 1. Because, right, but we wouldn't actually want to do that. We would want the millionth value to point to 0. So it'd be 0 up to, and not including a million, and then we'd have next map dot push. So 0, we would have this null. So we'd have 1 up to not including, and then we'd push 0 at the end. So that would push to the 0th value, right? Because that would push the pointer of the value. Okay, so we'd have 0, not including, and then we could have next map dot shift. Then we said next map dot push next map shift. So we'll push whatever the first element to make it a circle, and then that will give us 2 million. And then what we want to do is we want to do that, except now we're actually just, I think, at the index, right? So next map for v. Oh man. Okay, so now for v in index in values, we're overwriting the first 10, or the first 9 elements in the array. And we're saying, okay, so I want next map at index whatever, at index 0 to point to value. And I mean, this is the same thing as saying at next map. Well, whatever, this is fine. So let's try that. And since we don't need to, okay, we are going to need to have to set the head, and the head is going to be values. I guess the head is going to be 0. And then if we advance, so head is now like a pointer, not a pointer. So it's like an offset. To string, there's no fucking way we're to stringing this. So get rid of that. Labels after 1. So we want to find the index of 1. No, we don't. We want to. Right, so now we're going to have a next function, and that next function is going to be whatever so whatever the value of the current index, or I guess the head index is. So so we're going to have, was it map? Next map. Next map. So it's going to be next map. So that's the next value. No, that's not the next value. That's the... So the head is the value. And next map of head is the next value. So we could call that man, making it performant is tough. Okay, so I'm gonna have to debug this with an example, I think. with like a small example. Okay, so what do we got? So how is this gonna look when we're writing a list? And really, so really the list is just an array, and the array itself is a map, and we have to track our current position, which is head, in the list. And then when we call next, we want to set head equal to, that's if we advance. So we want to say head is equal to next map at head. So it's like that's going to be the next value. So labels after one, and we're going to have to want, we're going to want and find one, what we actually want the offset of 1, so the index of 1. So the index of 1, so this is going to be next map dot index of 1, next map, the next map, and labels after 1. Oh, we don't care about labels after 1 anymore. Okay, so we're going to care about shuffle, and we're going to care about move, and we're going to care about values after, which is find 1 and product after. Okay, so we're shuffle calls move, and then value after is really what we care about. After uses find, and find is just going through the list now. But what we're going to want to do is we're going to do index of val, and then we're going, that's the index. So that's the value that points to 1. Wait, maybe find we don't need an array accessor, and that gives us the next. So find is something that we don't care about anymore. Because it's always in the same position. It's just the next pointers that change. So, and the next for a val is next map val. Okay, so that doesn't, I mean, that's not like complicated. So why is that even a method? Why do we need this as a method? Maybe we don't. Cool. And then, so labels after 1, we don't care about anymore. We don't care about that anymore. So write. Write, what is write for? What do we want write for? Are we using write? Oh yeah, it's to look the number ahead. So write equals, and what is write? Write is just target next random. Okay, so this is moving is something that we don't necessarily care about. So write index is what we're gonna want to do. So okay, so so slicing cups out, finding the destination, all this stuff is going to change. So we're going to want, we've got the current index. So the current index is head. So the current index is head. Okay. Oh, sorry. got plumber calling. One sec. All right, and we're back. Plumber. All right. That's a good break. So, kind of tired. Okay. So we need to rewrite our move. We got to rewrite this whole thing to use a map. And the map is actually just an array. So okay, do we need write anymore? I don't know. Let's do it. And like, you know, do we even need next? I don't know that we need next either. Because we're just doing val plus 1, val plus 2. I mean, values get this idea of an item out of our head. And stop, just rewrite it. We know, let's keep all the notes that we have, right? So move the cups and then advance the head. And we're gonna do that times. Number of cups that we're gonna get is we're going to grab, so the at head. So head is the current index. What I'm gonna do is we're going to find the that's the current value is head equals was it next map? You know what? Because that's a lot easier to type. Okay, so equals map. That's the current next, and at whatever three from now is. So so that's head. So head plus 0, head plus 1, 2, 3. Head plus 3. So we're going to say that map head equals map of head plus 3. So we're creating a new pointer to that, and so that way and map head plus 3 equals to null. Okay, so the current next, and then we're going to need to put the current next. So where map, so map was pointing, let's say map was pointing at like 5, then we're saving that, and we're saying, hey map, you're now pointing wherever 3 ahead of you is pointing. Oh, but it's not 3 ahead because it's not necessarily sequential. It's it is sequential. Do we need to slice the array? God, I hope we, no, we're not doing that. We're not slicing the array, are we? God, we are slicing the array. God damn it. Okay. This is good. Slicing an array 10 million times is gonna be awful. That's right. We're just updating a pointer map. So okay, I'm getting confused. Maybe this is why I should have taken some CS course. Okay, so we've got our current next. So the next two, head plus 1, head plus 2, they stay the same because they point. Head plus 3 now points nowhere, and head plus 0, which is where we're going before, now points there. And now what do we do with the current next, where head plus 0 used to? We're gonna have to put that we're gonna have to put that somewhere. So we had like 0, 1, 2, 3 like that, and 4. Let's just say this is linear, and we're cutting out these 3, so we're saying 0 points to 4, right? And then we've got 1, 2, and 3. Why is it like this? There we go. 1. And then we're going to want to put this in somewhere. So let's say we had 4, 5. Let's say we want to put this in after 4. So now what we're going to have to do is we're going to have to do 0 points to 4, and then 4. So 0 used to point to 1. Oh, it's just the start is where it used to point to. Oh yeah, this is not how you access these. That's why it's not, it's map. Yeah, so we are going to need a next function, I guess. So next is going to have num equals 1. So next one, and then it was like 4I in 0 up to not including num. We're gonna say val equals so val equals head, and then val equals map val, and then we're gonna bring back val. Okay, so next 3. Or I guess this could be right, not next. Oh, it's the same fucking thing, isn't it? Okay. Where are we? So this is gonna be right. I guess this could be right. I mean, we could just call this right. Right cups. So start and end. So this is going to be our start value and our end value. And then what we're going to say is map of head equals map of right cups plus 1. Okay, so we don't need this stuff anymore, and this cur next and all that stuff. Get out of there. And then right cups. This is going to be map of E so what do we have? We have got this is the, and then so new next equals right cups plus 1. This is at map right cups plus 1. Okay, so map head now equals new next, and map E equals null. And then we want to find the destination, so we figure that out, and then we insert the slice. So okay, so we want to, so we've got these inserting the new slice. So we've got the start number and the end number. So what we want is we want to find the new right one. So we'll say here, let's just come on, insert the slice. We'll say right one, that's the new value. So map at right. Do we want to advance? No, we don't want to advance. This is going to be, yeah. So the map of right one, that's going to be the new head equals that. And what we want to detach start. So so new end equals map of right 2. And we're going to say new head. It's weird that I'm saying head and start. Anyway, new head is the value here. So I want new head, or map of new head, to be equal to start. And then map of end should be new end. Actually, I can just do map of end should be map of new head. And then map of new head would equal to start. And I don't need to calculate that because we're not putting them in like that. Right, okay, yeah. So, right, and right cups. Okay, and find val. We don't need to find val. This is just map of val. And then we want to go right 1. So map of val is the next val. And then product after is going to be so the value after, or is that the value? Yeah, that's the value that it points to. It's going to be, I mean, that's just right 1, except it's setting the head. So value after, okay. And then product after would be item 1 equals map val, and then item 2 would be map item 1, and then item 2 times item 1. Okay, so what do we got? We got let's shuffle 10 and see value after 1. Okay, so what do we got here? Error, unexpected new line. Yeah, we haven't run this in so long that it's probably completely screwed up. So to get line 43, unexpected new line. Line 43. Oh yeah, for v index in values. Okay, this find is not a function on line 79. Where's line 79? So line 79. Find dest val. So the destination is going to be. So what we're trying to do here, we're trying to figure out what the destination is. And the destination is just going to be val -1, unless maybe that's in the next 3. So how are we gonna figure out what the slice is? I guess what we want to do is we want to figure out. We want to have a slice, and the slice is going to be num equals 3, and see we can say for, and then we'll have red equals that. Okay, so for I in we want the next 3, so 1 up and 2 and including 3, what we're gonna do is we're gonna ret push, right, yeah, so what we're gonna have, so we're at the head, and this is gonna be the next, I guess this is gonna be the next 3. Oh, we already used next. I guess slice. Okay, slice 3 from head is going to be, so, or I guess head equals head. So we're going to start here, and then for I in 1 to 3, we can say head equals map h, and then let's push h, and then the new h equals map h, and at the end we'll just return ret. So slice here, we're gonna say find the destination. So we're gonna slice 3, and we're gonna say vals equals that, and so until dest, this head val -1 isn't correct either. So we want it to be, we want it to do is we just want to say head -1, so that's going to be the new head and the vals, and until new head in vals, we're going to subtract new head equals 1, and then new head equals 10 million -1 if new head is less than 0. Okay, and then immediately we're going to insert map right 1. So new head is map right 1. That's so we've already used this new head array, so this is going to be a problem. So find the destination. So the destination is head -1, and we keep subtracting, and then we don't need to find this destination again. Okay, so let's try this. So what are we saying? Push is not defined. Push. Push. Oh, that would be ret.push. Okay, assertion. So 10. So we're getting a value back. That's kind of cool. List shuffle 10 log list value after 1. So what if we do 11? And we want to remove assert. Okay, so value after 11. Let's say 15. This is not going fast though. Like, first of all, it's not it's not giving us a good answer. Second of all, I think it's slower than it used to be. So we're doing something wrong. Yeah, that's real bad. So this is not good. Maybe what we need to do is we just need to sort of like rethink entirely what we're doing. So we've got these values. See, at some point it's gonna just do so. For the most part, it's gonna go through the list 10 times though. That's the problem. And each time it goes through, it's going to take the thing. Most of them are sequential, so it's going to take the thing and it's going to move them left 1, but it's got to find that value every friggin' time. So constructor math shift. Okay, so let's see what shuffle does. Times 1. So let's say shuffle 10 times. It's going to say 10 times move the cups and then increase the value of head. And moving the cups is the slow thing probably. So move is, so the start, actually this is just going to be new map of head plus 1, and end is going to be don't I have a thing for this? No, I don't. Oh, it's right. Map. It's gonna be right. So right 1. It's a move. It's gonna be right 1. Right 1. And end is going to be right cup, so that is true, and that just goes and makes the value to the head, and then x times it iterates through the list and it gets the new value. Okay, and then so that's right 1 and right cups, and then the new next is going to be right cups plus 1. And do we care about new next anymore? I don't think we do. So this is going to just be and the map of right cups. So that's not correct, I don't think. I think we just want right cups plus 1 is the new next. So map head equals right cups plus 1. And that would be basically right 0. Okay, so map head, and then map end equals null, and then we're gonna have to assign map end equals, right, we find the new destination now, and then we set that, and then we set that head to new head, and then new head equals whatever the start value was. Okay, so why is this slow? It's probably this part here. So oops, find the destination. So new head and vals equals slice 3. So slice 3 basically does exactly this, but it gives us the results back, and this should be to num, up to 1 to num, and it doesn't matter because we're not using it. So was head, so we push head, and then we reassign head, local head, to whatever map of h is, and then we finally do that, give that back. So we pushed 3 things, 1 up to 3, so or 0 up to not including 3, doesn't really matter. Let's do that. So we're taking this slice, so these are the values, the slice values, and saying until new head is not in values. So that probably be right away. What is this head -1? Find the destination. So that's going to be the, right, okay, it's going to be the new number. Is going to be previous. Okay, and then it's going to, okay. So why is this so slow? That's the real question. Why does list shuffle 100 take so friggin' long? Let's say that's 1.2 seconds. 200 is 2.1 seconds. So 300 would be 3-ish seconds. Yeah, so shuffle is growing linearly. And all it does is it moves cups and then it adds 1 to the head. It advances the head. Oh, and this advances the head is wrong. It should be head equals right 1. Oh, should be right 1, and it should be equals to right 1. That's even slower. 2.7 seconds probably is. Okay, so let's see what let's see what 1,000 is. So yeah, it's gonna be awful. It's gonna be 10 seconds or something for 1,000, or worse. It's still giving us just 13s, the value after 1, but that's fine, because it's not likely to be changing. So maybe this array is a bad choice. So it's creating an array of 10,000 elements. And or 10 million elements. And the values of that array, maybe this is wrong, maybe it should be 1 up to and including 10 million. But anyway, so maybe that's wrong. So, or 0 up to and including 10 million. So that would be 10, because I'm thinking like 0 points to 1. Yeah, it would be 1 up and 2 including. And then 9, and then plus 0. Well, we don't have to do that anymore. Oh, didn't like that. Okay. 1, and then map push 0. So that would be 1 up to and including. That's not including. 1 up to and including. Okay, so it's still slow. So that's if we have this big array. If we had an object, but then no, then we wouldn't be tracking the next key of the object, like what next is anymore. Well, we don't need to ever actually, yeah, anywhere we're referring to head in here is probably head equals right 1, equals head minus 1. Right, that's the new value for head. Yeah, that's fine. Yeah, it's still slow. So what else could we do? So this was the array. So we're trying it with an array. What if we try it with an object? Maybe it would be faster, or maybe there's a more performant version of array that we can use. Because that's really that's how we're using this. So let's try this, and instead of push, map of index. Okay, so most of this is going to be the same, except by default, if we don't have a value, so where we're grabbing map of anything, what we want to do is we want to assume that if it doesn't exist, it's going to be val plus 1. Because the 10th element in the array would be, it would be equal to val. and then that'll write that to the array. So maybe we can just say or val, and then we don't need to write it to the array. And then or h, and then when we say ret h equals h, unless at h, or I guess what we want to do here is we want to, I guess we would set it to null. Oh no, this is ret. So ret h equals, what did this used to be? What were we doing? This is ret push h. Oh, because that's still fine. And it's map of h or h. Okay. And then here we're saying, so this is going to be assigning it equals right cups plus 1. So then find the destination. Do we have any pushes? I don't think we have any pushes. Is this faster? Probably a lot slower. Maybe it's the same. Yeah, it's just a hell of a lot slower. Okay, it doesn't like, yeah, 15 seconds. I don't know that we got the right answer. Probably because of all those strings. So, okay, it didn't, let's back out of there and go back to the array. So 200 is about 2 seconds. So this is not good, because 10 million is going to be it's going to be like 100,000 seconds or something like that, which is a lot of seconds. I don't have that kind of time. I guess the correct way to think about it would be like the amount of time that we could save by thinking about it more will pay dividends in the first run. Okay, time to think some more. Okay, so let's look at the problem some more. We got crab cups. Crab picks up 3 cups that are immediately clockwise of the current cup. So we have to think about this in terms of how we can track the position of each cup. It's the position of each cup. And the position of cup 10 million will be, I guess, 10 million minus 1. So what we could do is we could slice the array a million times. I feel like that would be super slow. Or what we could do, or 10 million times, I guess. Well, let's see how. I wonder how fast it would be. I guess we could find out how fast it would be by just trying it. We could try it like 1,000 times and time that, as opposed to, we could track, I guess what we want to do is we want to track the position of each element. So, but that's going to be just as slow. So if we have the value and then the position, then every time we insert things, then yeah, so that's why we really need to think about this as a linked list. And that's what we were kind of doing with the array, is the array would point to the next element. And that next element would be, yeah, so I guess the other thing we tried very briefly was we tried just adding a next to the integer itself, because that's really all it tracks. It tracks the value and then a next, but that didn't work. But what if we extends number? No, that's not. That's crazy because we'd have to instantiate a new number. I don't know that we could do that. Okay, determine which two cups will end up immediately clockwise of cup 1. What do you get if you multiply their labels together? Okay, so which two cups will be immediately clockwise of cup 1? Maybe there's a shortcut way to do this, because we're trying to sort of brute force it by going through every step. So let's try to think about it in the context of cheating. Let's say we have 1, 2, 3, and then on to infinity, and say let's say on to 10, and we don't. These are guaranteed to be in order 3, 1, 2, and the rest of these are guaranteed to be like 4 through 10. So when we start here, we start at 3, and then we go to 2, and then we go to 1, and then we wrap around and go to 10, and we go to 3. Oh no, so we start at 3, and because 2 and 1 are in the next 3, we immediately wrap around to 10. But once we've wrapped around to 10, then these would go here, and so these would get shifted down a bunch. I wonder if there's a fancy way we can figure out where 1 would end up. So we'd only care where 1 goes, or if we only care what happens to 1 or things immediately around 1. So maybe we can skip things that don't immediately affect ones that aren't plus or minus 3 of 1. So maybe that's what our optimization is because 1 is the only thing we care about. We only care about things that happen near it. So we only care about things that happen within a few indexes of 1. And then we can just skip moving the rest of it because we don't care what happens to the other jumbles. But maybe we do. Maybe as 1 approaches those other jumbles, we'll have cared. Well, we can try it. We can try it and see if that works. So we've still got this map. The map 0 to 10 million, up to and including, and then we're gonna map. So, and this is a map. It's going to be 1 because this is where it pushes, right? And then we're going to push 0, and then B index in values. Okay, cool. And then the head will be at 0. Yeah, that's fine. Okay, so this is still slow, but what we're going to do is we're going to shortcut move. And what we're going to do is we're going to try and look either side of 1. So what's the input that they give us? 1's in the middle, and then 1's in the middle here. So we actually have, we're going to keep track of the values near 1. So we'll call this care. or I guess care is bad. We'll call this near, and that can be, so values index of 1, so for I in -3 up to values index of 1, so we'll call this 1 index. 1 index equals boop. This should be 1 index is that, up to and including 1 index. actually we can just say at values. So we can say, okay, at near equals, so values up to including one index and, or not including one index, this is at values. Okay, and then values from one index up to and not including 3. So, okay, so these are the things that we care about. Okay, so so we're creating a new list, and let's log list.near just to see what we get. Okay, so that gives me nothing. Okay, near equals values. So let's log, whoops, let's log one index, so 3. So for values up until one index, this would be 0 to one index, and one index to one index plus 3. Not 0, this would be one index minus 3. Okay, so 3, 8, 9, 1, 2, 5, so up to and including. Okay, so this is going to give us 3 on either side. So if it's this value, then we care, whoops, and if it's up to one of these values, we care because that's around 1. So this is like the entourage. Okay. So we got, whoops, we got the entourage, and those are the values near it. Cool. So now what we'll do is in move, what we'll do is we will just return false if or unless head in near. I guess we just need to, we can just do that here. We can just do, whereas in shuffle, we'll move cups if head in near. And then these, we should be able to recalculate this. So maybe what we should do is we should near, so recalc, calc, near. We can say near equals, and that's going to actually be map now instead of values. Okay, so recalc near equals whatever, and this is a method, and then we'll call that here, calc near. We need, do we need the head? Yeah, I don't know. Okay, so what's this? One index is not defined. Oh yeah, okay. One index equals at map dot index of 1. Okay, so here's recalc near. So we're gonna do move. So every time we move, we're gonna want to recalc near. Okay, so let's see if it still does that. Probably not. It's probably going to fail, but let's watch it. Type of labels after 1 is no longer labels after 1. What the fuck is labels after 1? You know what? Let's just look at near after shuffle 100. List near, log, list near. Let's just see. Okay, so the list near has changed. And that happened a lot faster. 1,000, oh, good. Say 100,000, and then what's this? Is this, that's a million? Let's do a million. and 10 million. Okay, it took longer. But this isn't what we're expecting. So the value after 1 in that case should be 934,001. And why is that? It's because other values can get put into, right. So I guess what we're going to want to do is we're going to want to look if near or, so where's shuffle? So if head near or head so we want to be 99997 is less than, head is less than, I guess this can just be head minus 3 or head plus 3. There's got to be a better way of writing this. Yeah, if like head minus cups, this should be cups. Okay, well, let's try that. So that's going to take a bit longer. Which is good. Maybe we should calm down with the 10 million. So let's do 1,000. So it's still taking a long time. Let's do 100. Okay. So 200. This is going to be just as slow, isn't it? Oh, it's not head that I care about, is it? And near is 1. So yeah, it's head. So these are, because it's going to be, yeah, it's going to be moving the head around. Move cups. Recalc near. If head in near. So I guess what we want to know is we want to know if any of the numbers around head are in near. So let's get near head. Map index of head. Head is an index, isn't it? I guess if we want to know what's on either side of head. So so what do we want to know? We want to know, this is saying, okay, if I mean, that's always going to be true. That's crazy. I don't know why we're thinking that. Okay, so if head is in the nearby array, so the things that are close to 1, or head is close to any of the numbers in the nearby array. So if it's in near, or if it's close to any number in near. So if it's within 3, so this would be close to near. Would be for and in near, return true if so true if So head is the current number. If head, and we want to know if head is close to any number and near, but close in terms of, yeah, the problem is like we need to find out like we need to find like slice n slice, so at slice n, is that right? Slice, no, slice is head. So we want to actually find out index of n. So map index of n. So now we're going to be doing 10 calculations instead of like a couple, just to see if it's nearby. Fuck. Yeah, I don't think this is going to work. I mean, this was a long shot anyway. And it clearly isn't producing the right answer anyway. I mean, it was a nice idea. But like 200, what does 200 give us? 211, 12, and 10 million gives us 211, 12. So like, it's not just working. Yeah, that was 10 million. 859, 211, 12, 859, 211, 12. Yeah. So it just never comes back around. That's weird. I mean, it should be coming back around. Because it should move cups. And then we add 1 to the head, which, oh, that's not correct. Head should be equal to map head. Okay, so let's see if these change. 1 million, so 14, 21, 28. Yeah, they do. I mean, we can test our hypothesis pretty quick. And what do we want? We want product after 1. Okay, so let's try log list dot product after 1. Whoops. So this gives us 992. So that's not correct. But wait, what did they say here? They said after. Okay, in the above example, 10 million moves. Yeah, so this is not even correct. Under the 2 cups, crab is going to hide your stars 1 each under the 2 cups and immediately clockwise at cup 1. You can have them if you can predict what the labels on those cups will be when the crab is finished. Maybe we didn't even read the question right. Holy shit. Let's take another look. Okay, so due to what you can only assume is a mistranslation, you can quite surprised when the crab starts arranging many cups in a circle, 1 million in total. Oh fuck, there's 1 million cups, not 10 million cups, first of all. What the hell? So 1, yeah, that's correct. Okay. And is that the same number I was using down here? 1 million, okay. The remaining cups are just numbered in an increasing fashion, starting from the number after the highest number in your list and proceeding by 1 until the 1 million is reached. Then start counting up from 6 until the 1 million is reached. Okay, in this way, every number from 1 through 1 million is used exactly once. Okay. After discovering where you made the mistake translating crab numbers, you realize the small crab isn't going to merely do 100 moves. The crab is going to do 10 million moves. And the crab is going to hide your stars, one each, under the 2 cups that will end up immediately clockwise of 1. And you can have them if you predict what the labels on those cups will be when the crab is finished. So is there any way to shortcut this? I don't know. In the above example, yeah, this is tough. I'm going to see if anyone in here. I'm going to grab this and move it to the right. I'm going to see with hints for day 23. Part 2. All right, I'm gonna ask if there's anyone with hints, because maybe we'll get lucky and someone will give us a friendly hint. What are they saying? Me tackling part 2. Okay, this one kind of broke me. Linked lists. Okay, so they use linked lists as well. That's cool. When I try to run my test, he gets thread has overflowed its stack, and when I paste the test input, okay, ended up faking out a linked list with a big array of ints pointing to the next element in the array. Oh, this is like what we're doing. Okay, very fast to jump around, very fast to switch pointers, very hard to print or debug. Well, I got news for you. It ain't so fast when I'm doing it. Maybe it's because I'm doing it in JavaScript. JavaScript large array. Big arrays are objects. Browser performance. How to write fast, memory efficient JavaScript. Well, let's see what they give us here about fast execution. Okay, garbage collector, garbage collection. This is just mostly about browsers. Large object. This one call. Let's try JavaScript large array. How to handle large array operations in JavaScript. So let's see. My browser was able to set values for 50,000 elements. Okay. Adding slower running. How do I solve it? Recommend you load using Ajax. No, this is what? Speed up JavaScript array processing. Okay, let's see what you got to say. All right, Kevin, what you saying? Okay, the problem. You might not even realize how slow something is until you've made it faster. Yeah, that's true. So look at that, fill, and let's compare that to a native for loop. So that's map versus for. I can test each 7 times, pulling till core, whatever. Okay, our array method averaged 1.2 seconds. For loop was 3. Okay, so that's an order of magnitude, or not quite. That's less than an order of magnitude. 300%. Transducers to the rescue. Transduction is a way of processing a bunch of logic on each individual item by wrapping it in a recursive set of reducer functions before outputting a value. It's easier and cheaper to learn one thing well than to learn a ton of other things. I don't know if I agree with that. So I think he's talking about more complex stuff. Yeah, he's talking about like observables and stuff. This is absolutely not where we're going. High performance array transformations. Okay, so let's see what this guy has to say. All right, Hayami, I'm not sure. We spot obvious and blatant errors in the code, both in the article and the GitHub repo. I've corrected the bugs and bad assumptions in my original post. Okay. So counter, next step, reset, big array. So let's start with a big array. Oh, look at that. We can fill that. And then we want to fill this array with numbers from the counter. I'm going to have each number in the array. Okay, the fix, reduce. We can use reduce to iterate the array just once and perform all 3 operations in one go. 10 times faster. I mean, I feel like our array here is probably fine. Let's see what let's log list.values of 888 and just see what it gives us. Undefined. Oh, okay. Well, that's a problem. 888. Oh, it's not values. Map is what we want. Map. Yeah. Okay. So I mean, creating the array is not a problem. I think it's just mutating the array that's slow. It's not as nice as it could be. Yeah, I think they're all talking about creating an array, like a big array, and I don't care so much about that. I care about manipulating it, because that's sort of what we're doing. We're going to be doing something 10 million times, and it seems to be extremely slow. It's like, is it this part that's slow? Let's maybe we could time end. Is it recalc near that's slow? I mean, recalc near we weren't even doing before. So let's get rid of this near optimization, because I don't feel like near is actually helping us. I mean, it was faster, but it wasn't. It was hurting us more than anything else. So we're gonna shuffle 10 million times. So we're gonna move the cups and move the head to the new head. Move the head next. Oh, you know what? Yeah. So map. It's gonna change map. So map head equals right cups. Maybe this is wrong. And then map of E is null. So whatever. Okay. So this right cups. So right cups. This gives us the value there. Okay. And then map of E is null, and then we set map of E to map of the new head. What's this head -1? Yeah. A new head, not in vals. So in vals is slice 3. So slice. So we're creating this array every time, and we're saying for I. So this is the next 3. So is that what we want? We want start. We want to know. We want to say slice equals so slice equals that, and then for we can just say slice dot push right 1, slice dot push right 2, slice dot push right 3. Okay. Let's just do this instead of this vals. Okay, so slice equals slice push, and then not in slice. So this might even be slower. I don't know. We're gonna find out. So, well, new head until new head not in slice. New head minus equals 1 and equals 999 if it's lower than 0. Okay, so insert the slice. Let's see this. So undefined. This didn't even work. I mean, this is also terrible. Let's just do slice equals right 1, right 2, right 3. Okay. And what is it? What is this? List near is undefined. Okay. Let's check that out. Shuffle. Oh god, that's too many. Let's shuffle 100 and see how slow it is. 0.8 seconds. Let's do 1,000. So it's going to be 8 whole seconds. Yeah, because that's just going to be fucking ridiculous. So it's still very slow. 5 seconds, still pretty slow. If we do 10,000, that would probably be 50 seconds. Let's find out. So this gets the next 3 values. Next 3, not next 3. Next 3 is Natalie Wiesenbaum, who's the author of SAS. Very, very, very smart programmer. Okay, so next 3, and H, not in next 3. So next 3 should be 3 values. And yeah, this is definitely just going to take a while. Log next 3. And then let's turn this number down to like 50 or something. And we'll kill that. We'll start it again. Okay, so this is giving us our next 3 values. So it's doing it. And then we should probably log NH. And how often is this occurring? So -1. Oh no. Let's see here. Okay, so next 3 always. So 7, 6, until not in next 3. So like, what the hell? This is logging. So minus equals 1, but it's like it's always in the next 3. So how about while in next 3 nh minus equals 1. There we go. Okay, cool. So let's try that. Cool. So that gives us, I don't know what we're at, 50.2 seconds. Let's try 500. Okay. This is getting better. 5,000. Okay. Let's try 100,000. Okay. And then 1 million, 10 million. It's going to take a lot longer, and it's still always giving me 80. That does not seem right. So that gives us map of val. I feel like maybe we're not doing something properly. Okay, insert the slice. So map of E equals map of new head, and then map of new head is equal to S. So S and E are right one and right cups. And then, so we're taking it out and we're closing the loop. So that's map of head becomes right cups plus 1. Map of E becomes null. Okay. And then these numbers are fine. New head equals head minus 1. And then, so then we get the next 3. And while new head is in next 3, we subtract 1 from it. And if new head is now less than 0, we reset it to, maybe that's wrong. Maybe what we need to do is we need to set the new head to 10 million, but I think it's up to and not including 10 million. So 99999, or to 1 million rather. Okay, so now we insert the slice. So we have new head. And so we say the map of E is the map of new head. Maybe the map of E is new head. We want map to point to new head. And we want map new head. Okay, so let's try that. And so the product after 1, I mean, this should be a big number because it should be item 1 times item 2. This is taking a lot longer. Let's cancel that and try 1,000. So 1,000, 10,000, 100,000, million, getting slower, 10 million. See, between 1 million and 10 million gets real slow. And I wonder why that is. So we're no longer using slice, I don't think. Whoops. Not this slice anyway. Slice. And I mean, we could be using this slice. So next 3, let's try that. Next 3 equals slice 3. Yeah. And then let's try that with 1 million, see if we still get the same performance. 10 million. Yeah, basically it seems to be the same thing. I think I've got some node processes that are just humming away in the background. Oh, no, I think I killed them all. All right. So it's weird that this gives me 3, and then if I use at slice 3, oh, it also gives me 3. Okay, so I mean, this is clearly the wrong answer. That's product after. So let's say item 1. So the next 2 cups would be, item 1 would be, oh no, the product after. So that would be val. So that would be 1, and then item 1 here. Item 1 would be map val, or would be map of 1, and then item 2. Yeah, okay. So that would be 15, giving product 15. So let's put or log item 1, item 1, item 2. So -3, -5. Well, that's a problem. Why do we have negative indexes? Okay, so minus equals 1 if it's okay, if it's less than 0, we're gonna set it. That's if it's in next 3. We're gonna subtract 1. And maybe I've got this rule wrong. Oh, equals head minus 1. That's why. Okay. And we're gonna be like head plus 10 million minus 1 mod 10 million. Okay, let's try that. All right, so now we got 99 plus 3, but that's after what, like 1 million. Oops, we want 10 million. 10 million. Okay. I guess what we could do here is we could say just head, and new head equals head minus 1. And then we could do that just immediately after. Okay, so it finished in 33 seconds and it gives us this number. Minus 1. I mean, we can try it. Let's try to see if we're even in the right ballpark, and we're not, because look, these are the numbers that it's expecting to immediately follow it. That's the 389 number. So we're not even trying to solve that problem yet. So why is that? So if the new head is less than 0, we want to wrap around. Okay. And okay. So we're gonna subtract equals 1. Okay, so we got our head. So this is the destination. We're at the head. And we want to set the value equal to head minus 1. And if it's less than 0, maybe, oh, this is a 0 indexed. Right, it's the index of the array that we care about. So up to and including 10 million and 10 million, or 1 million. 1 million, is that 1 million? Yeah, 1 million, okay. And so we want to do that if is less than 1. And then minus will if it's less than 1, so if equals 1 million. Okay, let's try that. So this is giving us also very big numbers. Next 3. So let's shuffle it like 50 times. And we'll log that each time. Okay, so we start with, oh, we want to start with the head. No, the head is 0. The head is not 0. The head starts at the first value. It starts at map 0. Map 0. Okay. So 1, 642, and then that's the new head. What are we doing? Where's log? What are we logging? We're logging new head. So head minus 1. So it should start with the 3, and then it should go to 2, and then 1 is where it goes to. And then it starts with these 3, and it should go. Why is head? Oh, and then in move we're subtracting it, right? In shuffle, head equals map head. So then we set it to the next element. Okay. And then we end up with, well, that's weird. Map 1, and then map item 1, and log item 1, item 2. Why is that doing that? That doesn't make any sense. So we want to find, wait, why are we finding index of? Are we using index of? I don't think we should be. Okay, we're not. Okay. Okay, so we're finding the value of 1. So this is 1. This is where 1 is pointing. So this is the next value from 1. Is map value, and then item 2 is map item 1, and then we're logging those two together, but that doesn't make any sense to me either. So maybe we've screwed up our move here. So new head is head -1. Then we wrap around to 1 million if it's less than 1. And then we get the next 3 values from the current head. And that should be this basically. So we can do that. Okay, and that's giving us a different number. Oh, we're getting nulls in there now. Oh no. Oh no. So next 3, next 3 should wrap around. That's why. Okay, so next 3 for I, and we can say val equal, so index equals val plus 1 million mod 1 million. And then this is going to be index. I guess we can just do that. Okay, so that's still giving me nulls and undefineds. Okay. So we got index equals val, and if val, so we're going to do basically this same thing here. We're going to say val equals 10 million if val is less than 1. And this is going to give us some weird results. Look at that. We've got double indexes. Yeah, this is just completely messed up. I think I might need more coffee. Yeah. No one's around with any hints? No hints in the chat? No, nothing. Okay. Maybe what I need to do is I need to have a coffee, take a walk the dog. It's usually what helps. All right. Before I do that, I'm just gonna finish this thought quickly before I do that. Okay, so this is for write, but we're gonna have to do the same thing for slice. And then so index equals val. Oh, and then right, and then this is just going to be val, and then slice is going to be the same thing. Index, except this is going to be, so this would be val is head, and val push val equals val. This is the exact same thing, except what we're doing is we're just pushing it in here, and so write 1 would just be. Yeah, then we're here. Okay. So this was slice 3. Okay. So let's see what this looks like. So this at least is not giving us negatives. Oh, look at that. 1 million, and then we've got repeating. We got repeatings. So 6 is pointing to 6, 7 is pointing to 7. This is no bueno. So over here, I guess what we need to do is we need to slice. We need to get these next 3s before we start slicing things up. Next 3. And then no, we're still doing it. We're just getting the next 3 earlier. Where did I go? There we go. I guess we want the next 3 from the new head is what we want. So do we? No, we want the next 3 equals slice 3. And that's going to give us the values of these. So start is going to be next 3, 0, and end is going to be next 3, 2. Let's verify that. Log start and next 3, 0. Let's see if I'm crazy. And then E next 3, 2. So these should always be the same, and they're not. So I don't know what I'm talking about. All right, that means I need a break. I need a break, and I'm going to walk the dog. And we can put that here. And I'll come back to it. So I'm gonna stop this here for now, and I'm gonna come back to this with a fresh brain in a couple of hours after I've walked the dog and had some stuff to eat, had another coffee. So you can join me for part 2, or the continuation of part 2 of day 23 later. And in the meantime, I'll see you in a bit.